Here you have to be very careful and very methodic. So first we're gonna build the equation, and the equation is providing the height, and this equation finds the height based on the time. So if you're given the height, it means that you're given the solution based on time. So we are going to write the equation as 12, and then you bring the rest of the equation. 12 equals 18.8 minus 16.7 cosine of 2 pi over 5 t. And at this point, we are going to solve for the trigonometric expression. So here we're going to end up with 12 minus 18.8 equals minus 16.7 cosine of 2 pi over 5t. Now, 12 minus 18.8 looks like we're going to end up with minus 6.8, if I'm not mistaken. And this is equal to minus 16.7 cosine of 2 pi over 5t. And finally, we're going to divide. It's going to be minus 6.8 over minus 16.7. So that ends up as positive 6.8 over 16.7 equals to the cosine of 2 pi over 5t. So just like there are stunt doubles, we're going to need a stunt double. And we're going to call our stunt double. I'm going to use another color. I'm going to call it U. And U is going to take the value of 2 pi over 5t. So the meaning of that is that we don't want the cosine of something that is not simply t, simply x, simply theta. We want to turn it into a simple cosine. So if we send the stunt double, the rest of the equation is gonna look the same, cosine, and that is equal to 6.8 over 16.7. The only difference is that I have asked for the assistance of a stunt double, and that stunt double is gonna take the place of this, which is the original actor, the original value of the argument of cosine. Now, at this point, I'm gonna go back to problem 5, where I simply call the reference angle. And just remember the reference angle, I'm always gonna think of it as being here on the first quadrant. And cosine is 6.8 over 16.7. So I'm gonna say that x needs to be 6.8 over 16.7 comma y. And I'm gonna call that u prime, just for now. And I'm gonna say that cosine of u prime is equal to 6.8 over 16.7. It doesn't matter what sign I have here. In this case, that's positive. I'm always going to write the reference angle with the positive value, because reference angles are based on the first quadrant, And on the first quadrant, everything is positive. Now, because that is my reference angle, I'm going to write it as the inverse cosine of 6.8 over 16.7. So that's my reference angle. Now, what is my original sign on the cosine? That is positive. The original cosine is this one right here, positive. Where will I find positive x values? Both here, the fourth quadrant. So now I'll be working on those, but my reference angle always goes on the x-axis. So now this will also be 6.8 over 16.7, comma, y. So I'm going to be working quadrants 1 and 4. Now, those are the reference angles. The final angle is this. So that is U1. And the second possible angle is when I almost complete the circumference and I'm going to get to an angle of U2. Now, U1 is equal to simply angle 0 plus the reference angle U prime. So 0 plus U prime, because the closest angle is 0, or simply U prime. The second angle, U number 2, is equal to 2 pi minus the reference angle, because I did not reach I did not reach 2 pi. So I'm going to subtract the reference angle. Sorry, I wrote U1 as U prime. And same here, minus the reference angle U prime. So that's the second angle. What is U prime? I'm going to write it here. U1 is equal to 0 plus the inverse cosine, and that's the reference angle. The reference angle needs to be in terms of a positive value, 6.8 over 16.7, and here is going to be 2 pi minus the inverse cosine of 6.8 over 16.7. Now, I'm going to write those as U1 is equal simply to the cosine, the inverse cosine of 6.8 over 16.7. And my other is equal to 2 pi minus the inverse cosine of 6.8 over 16.7. Now, we don't care for U. U was just kind of like a stepping stone that was for us to reach this point. Now, it was the special effects magic, the sun double magic to get us here. Now, if you go back to movies, at some point, he does the hard work, the stunt double, and we just see at the end the actual actor. So we are going to bring back the actual value of U. So instead of writing U, I'm going to call the actor and I'm going to write 2 pi over 5t is equal to the inverse cosine of 6.8 over 16.7. And that's the same factor that I'm going to bring back here. 2 pi over 5t is equal to 2 pi minus the inverse cosine of 6.8 over 16.7. And simply, I'm going to solve for t. So t is equal, I'm going to multiply by 5 and divide by 2 pi. So that is 5 divided by 2 pi times the inverse cosine of 6.8 over 16.7. Go to your calculator and find exactly what that is. And this is going to be t is equal to 5 over 2 pi. And all of that is going to multiply what I have in there. 2 pi minus the inverse cosine of 6.8 over 16.7. And let's leave that to your calculator.